We will see what is the solid angle subtended by a rectangular plane. Till now we have seen the solid angle subtended by various surfaces. So let's see what is the solid angle subtended by rectangular plane and the square plane, right? Okay, I have taken here a cuboid. So in this cuboid, I have taken this rectangular plane, the rectangular face, that is ABCD with edge length LB, and this is the opposite face of this rectangular plane, that is at the center O. We have to find what is the solid angle subtended, right? Now, if h is the distance of this rectangular plane, or the distance between these two parallel planes, then the solid angle subtended at point O is given by omega is equal to sine inverse the dimensions of the rectangular plane, that is LB, divided by under root of it is L square plus 4h square times B square plus 4h square, right? So this is the solid angle subtended by the rectangular plane, or we can say at a point on the axis of the rectangular plane at a distance h. So we can put it this way also. So this is the distance from the center of the rectangular plane, that is through the axis of the rectangular plane at a distance h. Now, for cube, this will be the face center of the opposite face. So in case of a cube, we have length is equal to breadth is equal to height, means all the dimensions, all the edge lengths are same. So if we use L is equal to B is equal to H is equal to A, say, then the solid angle comes out to be, here as omega is equal to 4 sine inverse, it is A square, then divided by under root of A square plus 4A square times A square plus 4A square, because H is also equal to A. So that comes out to be 4 sine inverse. Then after doing a little bit calculation, so it comes out to be 1 by 5, right? Now, we can solve the flux problems also, because we know when we calculate the flux through a cube, we usually take that the flux through this phase, through all the faces is same, and we divide it by 5 and we say the flux through this phase is same. But that is not actually the case. The flux through this phase is totally different from the flux through these phases, that is this phase, and the bottom phase. So that will be same for the 4 phases, but for this 5th phase it will be totally different. Now, how to calculate the flux through this? If I take a charge Q here at the point O, that is at the face center, then flux through this opposite face can be calculated as it is Q divided by epsilon naught, then it is omega divided by 4 pi, where omega is the solid angle subtended. So it is Q divided by, it is pi epsilon naught, because this 4 and this 4 will cancel, so it is sine inverse 1 by 5. So sine inverse 1 by 5 you can calculate, and you can find what is the flux through this phase. Even you can calculate what is the percentage of the flux through this phase, right? So these types of problems we will solve later on in the upcoming videos. Now here the question for you is, what is the flux through AEHD? That is this, it is AEHD. So this phase is different from this phase. So the solid angle subtended by this phase is not equal to solid angle subtended by this phase. That we will calculate later on, and we can find the flux also through this. Now, if I take this point towards this face, say at center of the cube, that is the third case now, at the center of the cube, that means I am making this edge length now half. So the distance of the point O from the surface is only A by 2, not A, right? So for cube center, we have L is equal to B is equal to A. So in this formula, if we use L is equal to B is equal to A, and H is equal to A divided by 2, so then we can find the solid angle here. A solid angle is now omega 4 sine inverse, it is A square divided by A square. Then instead of H we will use A divided by 2, so it is A square by 4, 4 cancels, so A square plus 4, A square by 4. So what we get here, it is 4 sine inverse, it is A square divided by 2A square. Now a square cancels, we get 4 sine inverse 1 by 2, that is 4 times pi by 6. So solid angle subtended by this is 4 times pi by 6, or you can write it as it is 2 pi divided by 3, right? So solid angle subtended by each face is equal to 2 pi divided by 3. Then what is solid angle subtended by this closed surface, that is this cube at the center? So since it has 6 identical faces, so omega c is equal to 6 times the solid angle subtended by one face, that is 4 times pi by 6, 6 and 6 cancels, we get it is omega c is equal to 4 pi. So this shows us that the solid angle subtended by any type of closed surface is equal to 4 pi at a point inside the closed surface, right? Now we can do a question as we did earlier, the flux through the cube. So we first calculate the flux due to the charge through the whole cube and then divide it by the 6 identical surfaces, and we get what is the flux. Now with this method we can calculate the flux directly. So we have a charge at the center of the cube, we have to calculate what is the flux through the face. So here I have taken a charge and we have to calculate what is the flux through the face. So flux through the face is equal, it is q divided by epsilon naught, that is what is the charge here at this point, then it is solid angle subtended divided by total solid angle. So that is q divided by epsilon naught times 4 pi by 6, because we have already calculated this, it is 4 pi by 6, then divided by 4 pi, so that is q divided by 6 epsilon naught. Now since it has 6 faces, so if we multiply it by the 6, then we can calculate here flux is equal to, it is 6 times this, so it is 6 into q divided by 6 epsilon naught, so 6 and 6 cancels, so we get here it is q divided by epsilon naught. So that is the flux through the cube by a charge at its